So this week we are going to cover chapter 5, which is all about data transformation using specifically dplyr tools in R. So we'll just dive right in. Oops. There we go. Okay, so the outline of the chapter is as follows. We'll go through a little introduction. We'll talk about the filter function, the arrange function, the select function, mutate, summarize, and then end with group mutate. Okay, so data transformation helps you get the data in exactly the right form that you need. So it could look a lot of different ways, but some of the options are listed here. So you can create new variables, you might create summaries, you might want to rename variables, reorder observations, and lots of other things. And this chapter in the book uses the NYC Flights 13 package, which just has about 330,000 flights that departed from New York City in 2013. And the data comes from the US Bureau of Transportation Statistics. So this is just a peek at what the data set looks like. And so not all the columns are displayed here, but you might be able to, can you see my cursor? Let me know.
Yeah, it's visible.
Okay, great. And so we can only see some of the variables listed here, and then the remainder of them are listed below. And let's see, what does my next one say? Okay, so one of the things to point out here, this is just a shortened version of the data frame. But one of the things to look at is this row underneath the variable names, which has the class of that variable. And so I've listed 4 of them here. So there could be integers, like this one, doubles or real numbers. There might be character vectors or strings in a data frame, and there may also be date times. And those are the ones that are seen in this particular data set, but there may be other data sets that have additional classes like logical, factors, and just dates. Some of the basics of dplyr is that you can pick observations by their values using the filter function. You can reorder the rows using the arrange function. You can pick variables by their names with select. You can create new variables with functions of existing variables using mutate. And you can also collapse many values down to a single summary using summarize, which is spelled here with an S, but you can spell it with a Z. And it reads the same. And then there's also group by, which gets the above functions to operate group by group rather than on the entire data set. So in terms of how these functions work, the first argument is the data frame, and we'll see more examples down the road. And then other arguments describe what it is that we're going to do with that data frame, and then the result is a new data frame. So filtering rows with filter lets you subset observations based on their values. So for example, here we have our flights data set, and the data set is contained in the first argument here, and then it's filtered by 2 additional arguments. So there's month, which is set equal to 1, and then there's day, which is set equal to 1 as well. And so if we look at the data frame below, we can see that, well, we can't see the whole data frame, but we can see that it's filtered by January being the month 1, and then the first day in January, where the column day is also equal to 1. You can make comparisons when you use this function, and R provides sort of the standard set of comparison operators. So greater than or equal to, less than or equal to, not equal to, which is exclamation point followed by an equal sign, and then equal, which we're already familiar with, which is 2 equal signs. And then also there's logical operators that you can use. So the ampersand is and. The vertical pipe is what I usually call that. I'm not sure if there are other names for it. Is or, and then the exclamation point is a not. And this image here comes from the book, and it just shows the different kinds of operators that you might use depending on what you're looking for. Another thing to note is missing values. So missing values, which are also known as NAs, which are also known as not availables, represent an unknown value. And they're also contagious, meaning almost any operation that involves an unknown value will also be unknown. And this is also important because when you use the filter function, filter only includes rows where the condition is true. So it includes, or excludes, I think they should say excludes both false and NA values. So if you want to preserve missing values, you have to ask for them explicitly using, for example, the isNA function, which is located in the example below. So this one, in this example, it says filter, data frame is df, and then it's followed by an argument that has isNA x, and then another condition, which is x greater than 1. So this is one of the exercises in the book, in this particular part of the chapter. And the question is, or the prompt is, to find all the flights that were operated by United, American, or Delta. So these are all, or each of these are carriers. And so this shows just the first couple rows of the flights data frame, just so that we can look at the different columns. And we can see that the carrier column is included here before flight number. And then in this particular subset, we can only see UA, which is United. But if we were to consider all of the different carriers possible in the data set, which I've listed here, there's a bunch of different ones. And so UA is one of them, and then there's also AA, B6, DL, EV, and so on. So United would be UA, and then American would be AA, so American Airlines, and then Delta would be DL. And I've listed 4 different options here for how we might find all the flights that were operated by United, American, or Delta. So at this point, I was sort of thinking it could be a little interactive, and people could say maybe which option they might use if they were going to use the filter function.
I'm thinking option 4 or 3 would work, right?
Mm-hmm.
First 2 options fail?
Yeah, exactly. So we'll just go through these one by one. So option 1 is listed here, and it gives us an error. So the error is a problem with filter input. And this is because it's a really helpful error, actually, because it asks you in the end, did you mean carrier 2 equal signs equal to this? And so that's one way in which this particular example isn't going to work to answer the question that we're after. And so if we were to use 2 equal signs, that also is not correct because of the way that we set up the comparisons in the argument. And so, and you get an error message for that as well. And so option 3 is different. And so option 3, instead of having UA followed by the vertical pipe and then immediately by the other 2 carriers, this way of trying to answer the question lists each argument separately and then separates them by the OR operator, or the vertical pipe. And so that one did give us an output. And then option 4 gave us the same output. And so option 4 also works, and it's a little bit more, I guess, concise, you could say. I prefer to use this notation just because it takes up a little less space, and it becomes a little easier to read the code this way. And so this is just laid out by saying that we're filtering flights using carrier that is contained in the list that has these 3 different options. So it's checking for that and filtering based off of that. Okay, and then the next segment is arranging rows with a range. So this changes the order of the rows, so which means it just takes a data frame and orders it by a set of column names, or more complicated expressions if you want. So it orders a column in ascending order by default, and then you would have to use a different function or an additional function, DESC, to reorder a column in descending order. I don't know how you'd say that function. I don't think I've ever said that function out loud. Anyway, that's the descending function that you would use with arrange. And then a note here is that missing values are always sorted at the end. Okay, so this is another exercise, and this one asks us to sort flights to find the most delayed flights, and then find the flights that left the earliest. So this is just another snapshot of the data set and the data frame. And if we wanted to start with the first part of that prompt, so sort flights to find the most delayed flights, we might use arrange and then indicate which data frame we're talking about, which is flights. And then we're interested in the column that's labeled dep delay. And because we want to see which ones, which flights are most delayed, then we would want to sort from most delayed to least delayed. And then we'd have to use that descending function, which is around the variable name dep delay. And so here's another question for the group is, what would it look like to, what would this example look like if we wanted to find the least delayed flights?
I believe you would just leave out the descending function.
Mm-hmm.
So it returns the lowest, right?
Yeah, exactly. And so you wouldn't have to use any different kind of function because arrange by default sorts it in ascending order. And so yeah, so Eric is right, you would just remove the descending function from around that variable. Okay, the next section is selecting columns with the select function. Because sometimes we have data sets that have hundreds or thousands of variables, which can be hard to manage and work with if you can't see all of them. And so you might just want to narrow down to the ones that are most relevant to the questions that you're looking to answer. And in this particular data set, I think there's only, what, like 19 variables? Yeah, so there's 19 columns, 19 different variables, so it's not too bad, but there are definitely situations where you might be handling hundreds or thousands of other variables, and you might want to select columns so you can work with a more manageable data frame. Select gives us a way to narrow down to only those variables that we're interested in, so it's super handy. And some of the helper functions that can be used with the select function are listed here. So one of them is starts with, and then you would indicate a string to match the names that begin, in this example, with ABC. Another example would be if you wanted to find something that ended in XYZ, then you could use ends with, and then just indicate XYZ in quotation marks. Similarly, if you wanted to match names that contained IJK, for example, then you would use contains and then indicate what you wanted to match with. And then there's also matches, which if you wanted to use a regular expression, you could use that option. And so this particular example matches any variables that contain repeated characters. And then the book indicates that there's more about this that will be covered in chapter 14, which is about strings. And then num range is another really useful select tool. And in this example, it matches X1, X2, and X3. So that second piece of the argument indicates the number associated with the first argument, which is X. So I would like to ask the group here if any of these are ones that people tend to use a lot. I haven't personally played around too much with these, but I'm curious if other people use these a lot or find them useful.
Just seeing you go over this, I thought of I have a project that I'm working on where the contains is going to actually be a huge asset, because I basically I'm trying to create a table of, you know, what hospital beds are occupied at a certain point in time.
Mm-hmm.
And I'm like, okay, well, I can go and, you know, find the commonalities between our timestamps for the beds and our names for the columns for bed, and make sure that those are in there and turn that into, you know, part of the project. So this is actually awesome that we're going over this right now.
Nice. Oh, that's so great. Yeah, I think there might be lots of situations where I could use some of these, and I just haven't been, because I haven't like sort of seen them in front of me like we are now. One thing I really don't use very much at all is regular expressions whenever I work with strings. Like, I'm really not very familiar with how to use those efficiently. So when I look at this example in this list, I don't really know. I'm not even sure what I'm looking at, you know? So it's nice that it tells you what this example is, because I wouldn't know. But yeah, all very handy for sure. Okay, and then one of my favorite ones is the everything option, which is really useful when you want to move a few variables to the start of the data frame. And we'll talk about this a little bit more later on. When we get into the mutate function, mutate by default, so a mutate creates a new variable based off of variables that already exist. And when it creates that new variable, it puts it at the very end of the data frame. And oftentimes that's exactly the column that I want to look at. And so being able to select the column that I'm interested in and bring that new column to the front, and then everything else that I don't necessarily care about seeing right away kind of gets taken care of by this everything tool. So that's really nice, because otherwise you'd have to like manually list the columns that you wanted to keep, and that's just really tedious and not feasible if you're working with a lot of columns. Okay, so this exercise asks us to brainstorm as many ways as possible to select dep time, dep delay, R time, and R delay. So departure time, departure delay, arrival time, and arrival delay from the flights data set. And so this is a snapshot again of the flights data set, and we can see the 4 different variables that the exercise is referring to. So we have departure time here, we have departure delay here, and then arrival delay, and then arrival time. Okay, yeah. So all 4 of them are within view. So what would be, yeah, I guess maybe I have some examples that we can go through, but what would be some ways that we could use some of the tools we just went over to select these 4 columns? And I'll bring up that list again.
The 2 that strike out or that come together for me immediately are, literally spelling all 4 columns out and then having an or between them. And then the using ends with and then having time and delay as your ends with this or that. Okay,
nice. Yeah, I've got those included in this slide, so we can definitely go through those. Okay, so the first one is exactly as you said. It's kind of the most straightforward, the most obvious one, which is just to explicitly name those variables that you're interested in looking at and narrowing down to. And so this example, again, it states the data frame in the first argument, which is flights. And then the rest of the arguments are dedicated to naming the variables that you're interested in looking at. And so just like you mentioned, if you just indicate those variables in your arguments, then it will narrow it down to just those. And so we see a nice condensed data frame here of just the variables that we're interested in, which is great. Another one, excuse me. Another option might be to use the starts with option. And so in this scenario, we're using starts with to find the variables that start with dep, which would include ideally, right, dep time and then dep delay, and then also starts with R for arrival, so to capture arrival time and arrival delay. And so if we flip back to the last example, it's the same, the output is the same, right? The data frame looks the same, so these both did the same thing. And then the other option that we talked about was using, instead of using starts with, we could use ends with. And so that one doesn't look the same. And so here's a question for the group is why doesn't this option work?
Matching too many columns.
Mm-hmm. Yeah, because it's not just the ones that we're interested in that match up with those, I don't even know what you'd call it. I guess just with the way that you're selecting for columns, there's more columns that match those descriptors than we're interested in. And so this one doesn't quite work. And so I guess that's just something to keep in mind when you're exploring your data frame and you want to make sure that you're using the right tools and with the right names and everything. Okay, so the other step is, or the other segment is to add new variables with mutate. So I mentioned this a little bit ago. So this function helps you add new columns that are functions of existing columns. And it always adds columns at the end of your data set, like I mentioned earlier. And if you want to only keep the new variables that you made with mutate, you can actually use transmute instead of mutate. And I don't personally find myself using that one too much. Is that something that anyone in the group uses on the regular basis?
Not here.
Never.
Okay. Yeah, I just don't use it. I could see how it would be handy, I guess. I just don't, I don't know. I think I just like having it all there. Yeah, anyway, but that's an option. If you only wanted to keep the new variables, you can use transmute. And mutate can be used with arithmetic operators, so the kind of standard ones, plus, minus, multiply, divide, and then the caret. And then you can also use functions like sum. And you can use modular arithmetic with it, so integer division, remainder, and then log functions as well. And then some other things you can use with mutate are logical comparisons, like the ones we talked about earlier. Also offsets like lead and lag, and then other functions like ranking, so min rank, row number, dense rank, and then lots of other choices. Whoops, actually I wanted to stop there. So this is another spot where there's a bunch of options that I don't use myself. So I'm curious to know if any of you use some of these, like for example, offsets and ranking. I don't ever use those.
I use those all the time. You'll find, especially like row number and the offsets are very useful.
Okay, what kind of scenarios would you say you use those in the most?
For quartiles or percentiles, or you can do your own, you can give it a row number and then group by the row number.
Mm-hmm. Gotcha. Nice. New stuff.
And then you can also then use the row number as a filter.
Mm-hmm. Yeah, I could see how that'd be useful.
I've used the integer division sometimes to take something that is in 24-hour format. Well, something that I basically need to do, by the hour.
Uh-huh.
And luckily in a hospital, people are fine with using 24-hour format. So if you say 0200 or if you say 1700, they know what you're talking about.
Uh-huh.
So there are a lot of times where, I'll just split it up and say, give me the hour and the time that they came in. And I'm like, okay, well, we had this many people come in during this hour.
I could see how that'd be useful too. I wouldn't have considered that, but yeah, definitely. And I guess that's something that's handy with this data set too. I don't remember if there was an example using that in the book. But I do think that there's a variable where that could come in handy there too.
Yeah, and if you group by and then do row number, that can be super useful as well, because you can actually index within groups.
Mm-hmm. Nice, good to know. Thank you. Okay, and then the next segment is about grouped summaries using summarize. And this collapses a data frame into a single row, and then it's more useful. You can use it on its own, but it's more useful when you combine it with group by, which has been mentioned a couple times already. Arguably, it's most useful when used with the pipe operator. Now, I realize as I've been flipping through these slides that I've already used the pipe operator, so I apologize that I introduced it before talking about what it was. But we'll talk about it a little bit more now. So the pipe operator lets you go from something like this, which is, in this example, we're assigning to by dest, group by, and then flights and destination, or dest. And so it's literally taking the flights data set and grouping it by this variable, which is the destination. And then we're assigning that to by dest. And then the next step is to use summarize. And so in this step, you're summarizing by dest, which you defined earlier. And then you're counting the number of observations, and then you're creating some additional variables using the mean function, for example, and then you're assigning that a new variable name. And so if you wanted to use the pipe operator, which I recommend, it would look more like this. And so instead of having to do these intermediate steps of saving a series of steps and assigning it a variable name, you could just start with your data set, and then you could do steps sequentially after that. And so it's one step after another, and the pipe operator lets you break those steps up neatly. And so it looks a little bit different because instead of, actually, I'll stop here. So what are some of the things that stick out as being like, if we were to play like spot the difference between the two examples, what would be some of the things that look different between the two, aside from the pipe operator?
The big thing is not having to declare the data set every time.
Yeah. For sure. Yeah, so in the first example, you have your data set and the first argument, flights. And then in the second example, we take that out, and it exists outside of that function. And so it's feeding into the functions that come afterwards. And because you can just do one step after another without having to reintroduce the data set, it does become really useful in that sense. See if there's anything else. Yeah, I think that's it. I think the rest of the stuff looks the same. But yeah, that's definitely a huge one. So you have your starting point, and the way that you can think about it is you have your starting point, which in this scenario is your flights data set, and then you're feeding it into these functions. And so the first step is you're grouping by destination, and then the second step is you're summarizing and creating some new variables. And then with group mutate and filters, they're most useful in combination with summarize. And for example, we have popular dests, and that's being assigned to flights, piped into group by destination, piped into filtering. And so there's like a filter argument there. And so the question for this section is, what does this do? Like, what is this example doing? What are we trying to find out by running this example? Any guesses?
Is this flights that run more than once a day? Destinations that are flown to more than once a day?
Oh, that's a good question. I mean, yeah, you're grouping by destinations, you're filtering. Yeah, that's a great way to think about it. Yeah, I don't think that's explicitly how it was mentioned in the book, but yeah, I think that way makes more sense. It's a little more intuitive. Um, but yeah, you're exactly right. So you have this flights data set that you start with, and then you're feeding it into the next step, which is to group by destination. And then that's feeding it into a following step. So once you've already grouped by, then you are filtering that by destinations that have more than 365 observations. So yeah, you could think about it like more than once a day. So they're popular destinations. That's the whole point of this exercise here. So nice. I
That's
think
super powerful.
yeah, definitely. Or you mean group mutate in general?
Or that the option to filter by a summary value that you're not actually, but you're not producing a summarized thing. You're able to filter by that summary, even though it doesn't output a summary. Like that's great.
Yeah, yeah. I hear what you're saying, because I oftentimes, if I want to, like, I find myself making new variables like all the time. Like I'll use mutate often, and I'll make new variables and then refer to those new variables. And so I don't often, take this approach where I'm kind of summarizing something within the pipeline. But yeah.
Yeah, me either. That'd be a nice technique to add.
Mm-hmm. Yeah, definitely. Okay, friends, I think that might be it. Yeah, that's the end.
All right, that you had a super dense chapter to have to break down into, whatever amount of time we have, and I think you did a fantastic job here. So thank you for that.
Thank you.